Hello everybody, this is Art and you're watching Seeker Vision. This is episode 7, part 3, entitled The Rhythm of the Elliptical Orbit. Alright, years ago now, I started seeing YouTube videos on the grand solar minimum, and there's a complete second chain of thought out there. Lots of scientists believe that CO2 is going to warm the planet up, but there's another group of scientists that believe that no, we're actually due for a cooling period. The interglacial period is almost drawing to a close, and we're going to go into a more dormant period where our sun is more dormant than what it is right now. From about 2020 on up to about 2008, the sun was at a solar maximum, and it appeared to be agreeing with what the global warmists were saying. But then about 2008, that output of the sun tapered back a little bit, and now it's getting cooler. Now we're seeing record cold. We're seeing first time ever freeze in Havana, Cuba. We're seeing snowfall, blizzards, shutting down highways in Montana in the next to the last day of June. There's bunches and bunches all over the world of extra cold records being set. So at this point, I started looking at the planet as a machine, and the more like a circuit, because I come from an electronic background, and I see a complete circuit where the background temperature of space is the big elephant in the room. Then you have the small little planet Earth, and then you have the sun. The sun is the only body with any ability to really warm the Earth up in any appreciable way. Without the sun, if the sun completely extinguished, the Earth would just turn into an ice ball, and it would go down to the background temperature of space at minus 455 degrees. So I see it as a complete circuit, and when people tell you, well, the Earth is going to warm and the sun has nothing to do with it, I just see that as being ridiculous. That's like you're in a tent and it's minus 40 degrees outside. You're sitting at a table and you have a little chair that rotates and you have one little heater sitting in front of you. So you get on your stool and you start spinning around so this heat can warm up the central part of your body. But you have frost on your head and you have frost on your feet. And now somebody comes in and says, well, I'm going to move that heat back a little bit because it's not doing any good. Well, that's totally ridiculous, because that's the only heat you have. The sun is the only heat we have. It's the only provider of heat. If the sun starts decaying, its output starts decaying, the Earth is beyond a shadow of a doubt going to feel it. So what does this have to do with the rhythm of the elliptical orbit? Well, a elliptical orbit has points where we're closer to the sun and further away from the sun. The furthest away points are called aphelion, and that just occurred on July the 6th of 2026. And at that point, we're 94.5 million miles away from the sun. Perihelion, on the other hand, is the point at which we're the closest to the sun. And perihelion occurs January 2nd of 2027, and we're going to be 91,406 miles from the sun. And that distance, that change in distance, seems small, but actually it's quite large. It's greater than 3%. And 3% in a formula with the exponent, a 3% change turns out to have a pretty significant impact. So when I first looked at this orbit, I thought to myself, wow, this is great. We're heading into a grand solar minimum, and what luck. The sun is closest to the Earth, or should it be the other way around, the Earth is as close as it's going to get to the sun all year. So that's useful to us in the northern hemisphere. But then I started looking at the complete picture, and the complete picture is, well, we are closer to the sun, but the northern hemisphere has a great deal more land mass than the southern hemisphere. So the northern hemisphere has what they call continental flow, and when winter storms start moving over the land and the land's cool, they start reaching further and further into the south. But on the other hand, in the southern hemisphere, during their winter, which is right now, they're at a point where the sun is further away from them. So that greater distance from the sun allows them to cool. So this is kind of, this particular elliptical orbit looks like it's going to have a impact on both hemispheres. Both hemispheres are going to have the ability to cool down. The northern hemisphere has the advantage of a greater landmass during its winter, allowing cooling, and the southern hemisphere is a greater distance from the sun, allowing them to cool. So you have two hemispheres, and during a good bit of the year, there's overlapping snowfall. There's snowfall in the northern hemisphere. Right now it's winter in the southern hemisphere, so obviously there's snowfall there. But this overlap extends for probably better than half of the year. All right, with both hemispheres on planet Earth being able to cool down simultaneously, this is going to have a tendency to possibly put a little squeeze on the atmosphere at the equator, because you have cold, heavy air in the northern hemisphere and cold, heavy air in the southern hemisphere. The weight of that cold, heavy air could have some compression effect on the air at the equator. And if you create a greater contrast in temperature, you're also creating the potential for larger winter storms and more violent winter storms. And one other possibility is that this compression of temperature can give you, on the surface of the Earth, some misleading temperature information. My belief is, in the advance of a possible global cooling event, the best indicator would be freeze altitude. You may not know this, but in most places on planet Earth, if you go 3 miles up, you're going to be in freezing weather. That's what separates you. That's the only greenhouse area that you have, is 3 miles. And walking at a leisurely pace of about 5 miles an hour, you could walk, if you could walk straight up, you could walk from heat on the Earth to freezing temperatures in less than 1 hour. So that's the thin layer that we're talking about, dangerously thin. Now, if cold air is riding and increasing above that warm layer, the weight of that cold air pushing on that layer of warm air would have a compressional effect. So you may have these patches of warm air, and their heat and temperature in those patches of warm air is exacerbated by continuous cold fronts that are moving down through the summer. There's continuous cold fronts, probes of cooler air moving from the pole down, and that probe is pushing the heat out of the way. As you know, energy can't be created or destroyed, so it's more condensed in certain areas and it's heated up. So a terrestrial temperature check would probably not tell you as much as freeze altitude. If the freeze altitude is continuously dropping, the terrestrial temperatures may actually rise, but you're closer and closer to that freezing temperature at all times. At this point, I want to just wrap up the discussion about the elliptical orbit, and I'd like to give you something that you can watch closely next season and see if it doesn't play out like I'm saying. The next winter, because there's so much snow in the northern hemisphere, is probably going to start kicking in the lower 48 at some point in August. We're probably going to see snowfall in the lower 48 in August. Winter effects every week after that are going to increase, get more aggressive, move further into the south until you get to December the 10th. At December 10th, your sun is moving quite a bit closer to the Earth, and there's a period where these aggressive winter movements start abating. And January 2nd, you are at your closest point. About the 20th of January, you're in a bookend position, the same altitude as December the 10th, except now the land masses have already cooled down because of the previous winter thrusts. So now you're in the same altitude sun, so these winter fronts are going to push, and they're going to come in, they're going to push further, they're going to reach further into the south. They're the kind of cold fronts that are going to start freezing adjacent to the Gulf of Mexico again. And the winter really begins in earnest about the 20th of January. So you'll be able to watch that and confirm with your own eyes that, yeah, the sun makes a difference. It's going to get colder, colder, colder. The sun's a little closer in December for about 40 days. The sun is relatively close, then it starts gaining altitude in the sky, then the winter fronts have the power to push further into the south and create bigger storms. So that's something you can see with your own eyes, and seeing is believing. So we'll move on to, I wanted to discuss in the last video I made, I mentioned 3 things that can create cooling. And because the sun is going to go into decline, there's quite a few more things, and I just want to really quickly go through them so you have it available to you, the things that are going to happen if the sun indeed goes dormant, things that are going to happen that are going to add to the possibility of cooling. All right, momentarily on your screen there's going to appear a chart, and the chart is taken from spaceweatherlive.com, and it's a chart of the number of days with a geomagnetic storm per year. And you'll notice the left of the chart was during the period of time when we had the solar max. If you look towards the right side of the chart, you're going to see the previous solar cycle 24, and the current solar cycle 25. Now, the number of days with geomagnetic storms is greatly reduced for these 2 solar cycles. So what appears as though we're going to have solar cycle 26 following 2 consecutive very weak solar cycles. The first conclusion you should come to when you look at this chart is that the reduction in geomagnetic storms probably will result in weaker incident heat hitting the Earth from the sun. But in addition to that, the geomagnetic storms and solar plasma have the ability to sweep cosmic rays away that would normally penetrate the Earth. These cosmic rays do several things. One is they do what they call cloud nucleation, and they create the ability and little tiny subatomic particles that moisture can cling to, and it creates clouds in the sky. These additional clouds raise the albedo of the planet, the reflectivity of the Earth, and now more incoming sunlight that was destined to arrive at the Earth hits this heavier cloud layer, and it's reflected back into space. Some of the cosmic rays penetrate deep into the ground, and they have the ability to agitate and heat up volcanic magma, making it more probable that you have a volcanic eruption. If the eruption is big enough, high enough, it can cause aerosols to get in the stratosphere, and those aerosols are highly reflective, and they can orbit the Earth for several years. And another thing that's possibly going to cause additional volcanic eruptions is the fact that we're going into an even solar cycle. And physicists say that, when you're in one solar cycle, a positive solar cycle, the magnetic field of the Earth and the sun are in phase. In the even cycles, they're in opposite phase. So that would put stress on our magnetic field. Well, that stress can translate into increased earthquakes and increased volcanic eruptions. I've added a couple additional charts, and these charts are charts of cosmic rays that are monitored here on the Earth. And the chart starts, they actually started doing this in 1965, and you can see the cosmic rays going up and down, up and down. They're at their highest when the sun is at its weakest output. They're at their lowest when the sun is at very high or maximum output. So the very last picture is going to be a little blow up of our current solar cycle, and you can see very clearly that we have been at the peak of this solar cycle. During the peak of this solar cycle, which is a negative lobe, the cosmic rays are low because you're at the peak, so you're looking at a negative lobe, but that negative lobe is starting to make a rise. The rise is going to continue until you start getting some of these effects. As the solar activity weakens, the cosmic rays are going to rise, and you clearly see that this solar cycle, we produced, even during its peak, a lot of cold records. We had, as I mentioned before, freeze in Havana, Cuba. We've had snow in the deserts in Saudi Arabia. There's been a lot of almost unexplainable cold activity, but it's easy to explain if you believe that the Earth, not the Earth, but the sun is going into a more dormant phase. Now, how long will it last? According to some solar physicists, probably until 2053. So if you look at the last chart, look all the way to the right, you can see the cosmic rays are starting to raise. Probably before this time next year, they're going to cross the 0 point, which they consider that, average cosmic rays. When they cross that 0 point, they're going to go into the high range. When they go into the high range, we start getting our heavier cloud layer caused by cosmic rays. We start getting our penetration into the ground, heating up volcanic magma. Well, what are the first big indications that you're going to see the effects of this cold weather? Some of it's already started in various places around the world. Crops that used to grow at the latitudes they're at are now suffering. Olives, grapes. Here in the Texas area, we had loss on our blueberry trees because an untimely freeze hit after the blooming started. But it's going to get a lot worse from there. In the south, most of our trees are evergreen trees, and most of them are filled with leaves. When ice storms start moving into the south, and we're not far from that happening, it came very, very close to hitting Central and South Texas this last winter. It wouldn't surprise me one little bit if we get ice storms in the winter coming up. And when that starts happening, because we have so many leaves in the trees and pine needles in the pine trees, leaves on the trees, the weight of this ice is going to tear branches down literally by the trillions all through the forest in the south. Does that leave fuel load laying around for future fires? Well, I think it just might. So I think people better beware. They better get rapid response fire equipment ready for it, because it's probably coming. And one little idea that I came up with, one of the other impacts of ice storms is weighting down the power lines, and the ice becoming heavy enough to break power lines. So I came up with an idea where you might be able to tap into a high voltage power line, and you might be able to transform that electrical power down and then rectify it, and then through a current limiting regulator add DC, that if you put a 60 cycle inductor in front of it, you can introduce it back in the line, let it travel down the line, and the DC at some point 100 miles away, you'd have another reactor that would block the AC, allow the DC to pass and go to ground and form a ground loop. So you can create DC at one end, send the DC down, and have it return through ground. And that DC is much more capable of heating up those power lines. So that's one idea that I've thought, and I'd like to put it out there because I think it really should get a feasibility study to see if the only thing that's in doubt is if you have a 60 cycle reactor that can block the AC from going into your DC circuitry, and vice versa on the other end, a reactor that can allow the DC to pass through it and hit the ground. But basically the idea is a good idea, and running DC down those power lines can heat them up and prevent the ice from tearing the power lines down, because a super large ice storm down in the south with the trees we have filled with leaves, it could bring down power here for, well, let's just say a protracted amount of time. So anyway, I just wanted to pop that idea down. Hope somebody hears it, hope somebody gives it a feasibility study. And with that, I'm going to go ahead and close this segment of the program, episode 7, and I'm going to get back to the original mission statement. But this was all just too close, too important, too life-threatening to just ignore. So I really needed to put this out, and hopefully somebody will do the right thing and make some preparations for the cold weather that's probably in their future, or at least look at it, keep their ear to the ground, and form their own conclusion. At any rate, goodbye for now. God bless. And we'll start episode 8, and I guess I'll just call it Back to the Original Mission Statement. Thank you. Amen.